Well, good afternoon, everyone, and welcome. It's a pleasure today to host a special seminar that will be delivered by Professor Mehdi Ahmadian. I'll say a few words to introduce my longtime friend and colleague. Mehdi Ahmadian is the J. Bernard Jones Chair of Mechanical Engineering at Virginia Tech. He's the director of the Center for Vehicle Systems and Safety and the Railway Technologies Laboratory. I visited his labs in the recent past, and it was the first time I'd seen rail stuff in a long time, other than crossing the railroad tracks between campus and car. Professor Ahmadian has co-authored 8 books, 4 book chapters, and more than 500 journal and conference papers. He has delivered over 400 technical presentations, including numerous keynote and plenary lectures and many invited talks. He holds 12 U.S. and international patents, with some patent applications pending. He's a fellow of the American Society of Mechanical Engineers, SAE International, and the International Society for Condition Monitoring, as well as the International Institute of Acoustics and Vibrations. He's also an associate fellow of the American Institute for Aeronautics and Astronautics. In 2024, Professor Ahmadian received the 2024 SAE Medal of Honor, the highest recognition of lifetime achievement given to one SAE member each year. He also received the 2023 Virginia Tech Alumni Award for Research Excellence, the most prestigious award at Virginia Tech for significant lifelong research contributions, the 2019 SAE Magnus Hendrickson Award for Innovation, and the 2014 SAE International L. Ray Buckendale Award, which a few years later I was also a recipient of. So we're Buckendale buddies. And today, Professor Ahmadian will talk to us about the journey that the automotive industry has undertaken from the Ford Model T to autonomous vehicles today. Please, let's welcome Professor Ahmadian to Ohio State.
Thank you so much, Giorgio, for that amazing introduction. It's a delight to be here, and thank you for making time to attend my presentation. I also would like to extend my thanks to all of you who are online. The topic of my seminar today has got a little bit of historical perspective associated with it, and I'm hoping that we can sort of march down the memory lane and come to these wonderful autonomous vehicles that we either have or strive to have in our daily lives. Before I go on and tell you about my talk, let me just go ahead and tell you a little bit about our center. I am the director of the Center for Vehicle Systems and Safety. As the name implies, we play within the domain of vehicle dynamics and as they relate to safety of vehicles. The center has got 2 distinct parts associated with it. One part is the Railway Technologies Laboratory that deals with railroad dynamics and railroad vehicles. And the other one is the Advanced Vehicle Dynamics Laboratory. Today's research in the vehicle dynamics side of our work is mostly related to safety of commercial vehicles and semi-trucks and that sort of thing. My past runs through the passenger vehicles, a lot of suspensions, dynamics, and so on and so forth. And it's been delightful because I had a chance to talk with some of your colleagues here who had worked in the same space. At any time, we have a number of faculty members and students and postdocs and so on and so forth that are associated with our center. We're not too unlike Automotive Research Center, ARC, except that we are a lot smaller in size and stature. But nonetheless, we kind of play in some of the same space. We were established in 2005, and we have been going strong for the past 20 years. And I'm hoping that we will continue to go strong. We've had a number of organizations and companies that have paid the bills over the years. Again, I like to show their logos because we are absolutely grateful for them for helping us sustain our research. When we talk about vehicles, we take a holistic perspective of vehicles. We have had research projects on all types of vehicles, even water vessels. Many years ago, we had a project with the Office of Naval Research where we were analyzing the dynamics of these high-speed boats for Navy applications. And the reason we had got involved with them was because these catamarans have got soft pontoons, and they've got a superstructure, or they've got a trailing arm system that connects to the superstructure over here, and it's got a suspension. And of course, us being the suspension folks, they had come and found us, and so on and so forth. Again, as I said, we do a lot of testing on rails and railroads, and that's a good part of the research that we do. I guess, in short, if it's got challenge in it, if it's got dynamics in it, if it makes us think and create and invent, then we're interested in it. And we make it our business to learn whatever we do and kind of work with it. So it's been an amazingly fun journey. And now that I've told you a little bit about us, I'd like to get back to the topic of my seminar, which is sort of how we got from here, or how we got from the Model T to today's autonomous vehicles. And notice that I am starting with Model T because Model T is hailed as the vehicle that truly had a profound impact on the society. It kind of revolutionized the transportation by making it accessible and putting it within the economic means of the average person. Some may want to call that the middle class. In fact, as you may know, Henry Ford made it his business to make sure that he pays his workers on his assembly line enough that they could afford to buy the vehicles that they were making. In many ways, he was a revolutionary. Of course, as again you may know, Henry Ford and Model T was the first vehicle of its type that was assembled on an assembly line. So even that was an innovation in itself, and Henry Ford was personally involved in both the design, engineering, and manufacturing aspects of this vehicle. So I kind of like to think about Model T as one of those seminal moments in our transportation history, and I am connecting it to today's autonomous vehicles simply because I believe that the autonomous vehicles provide a similarly seminal moment in transportation history. We're going to talk about autonomous vehicles a little bit more later on in my lecture. And again, as I said, beyond the novelty of engineering that the Model T offered, it was something that had profound cultural, lifestyle, and social reach. It connected people who lived in the suburbia with the center of the city or places that they worked. It literally contributed to expanding the reach of the cities and people who lived in it. And it was the first time that sort of people ventured to travel, and perhaps you could call it the start of the tourism industry. Prior to that, traveling by either public transportation or other means that we had available to us was quite arduous and required a lot of planning, and one could also argue that it wasn't really that comfortable. So therefore, people really didn't venture in it. And so it was quite a creation in itself. Now, before I go too far, and kind of, I know I started with the Model T, and in some ways I kind of jumped ahead of all of the events that perhaps had come prior to Model T, and I don't want to ignore some of the events that have happened since the Model T. So if you will allow me, I'd like to take a stroll along the automotive history and tell you about some of the innovations that I have found significant, or at least interesting, in some of the readings that I have done in this area. And again, this list is not intended to be an all-inclusive list. It is simply intended to be a sample of some of the things that we've got in our vehicles and we enjoy today, and how they came about to their existence. Carl Benz, back at the end of the 19th century, patented the world's first automobile. And he had this vision of putting a power pack, a power system on board what prior to that had been always powered by live animals, horses. And he received a patent for the automobile. Another significant event was at the turn of the 20th century, and Porsche showed the first hybrid car at the Paris World's Fair. Interestingly, most of us think of hybrid vehicles to be a thing of today's creation. And if we go to the beginning of the 20th century, we see that, visionaries such as Porsche had the same thing. It just so happens that Ferdinand Porsche had a profound effect on the transportation industry. Not all of it, in my opinion, for the better. Certainly in terms of the technical aspect, he had a lot of positive effects, but one could argue that in some of the social aspects, he did not necessarily have a positive impact. But nonetheless, it's really interesting. And some years later, Mary Anderson invented windshield wipers. And as you may expect, she was well ahead of her time. She was truly a trailblazer, and the industry ignored her. I do not have any confirmation that it was because she was a woman. And of course, we are talking about a time in history that there's, a lot of sexism, and perhaps a large portion of the society is ignored, but nonetheless, she prevailed. Needless to say, the story goes that she was on a trip to New York City and noticed that the drivers have to reach physically outside of the vehicle to wipe their windshield wiper. And the inquisitive person that she was, she thought, well, there's got to be a better way of doing this. So she invented this mechanism that would allow the driver inside the vehicle without reaching outside the vehicle to simply move a handle and operate a windshield wiper. Now, I am sure that a lot of men had made the same observation that she had made. And none of them really had stopped to think that, can I do something better? You know, there's got to be a better way of doing it. And good for her, you know. So, you know, I've always believed that women are clear thinkers and they are detailed thinkers, a lot more than most of us men are. So over the years, I've learned that if a woman tells me something, I sit upright and I pay attention to what they're saying, because more often than not, they are saying something really important. And I can share with you that my wife is really proud of me for that. Or she takes all the credit for it, right? She says, I taught him well. So moving on, you know, comes a newcomer, Rolls-Royce, and it introduces this real fancy car that they call the best car in the world. It is a 6-cylinder beauty. It's got a 7,000 cc engine, 80 horsepower. It's got a 3-speed transmission, and it has spark plugs in it. So again, another big revolution in our thinking, in transportation and cars and so on and so forth. And perhaps this was the prelude to a lot of the technologies that came about afterward. In fact, if you look at this vehicle, and if you look at the vast majority of the cars that we drive today, there isn't really a whole lot of fundamental differences between them. The form, fit, and function are still the same. It's just that you know, some aspects of how we implement them have changed. So that was also equally interesting. And notice that all of this is before the creation of Model T. Charles Kettering, who went on to become one of the most influential CEOs of GM, and he was the founder of Delco, invents the first electric starter to replace an engine crank that was implemented in a Cadillac. Now, I see a lot of young faces in the audience, and perhaps I'm going to show my age, and I don't think any one of you remember life before electric starters. But I do remember in my childhoods riding in Jeeps that had a hand crank starter. And if that engine backfired, that starter could backfire and hit you in the teeth. And I'm sure that a lot of people had lost a good number of teeth as a result. Again, another big innovation. In fact, that was the innovation that kind of put Delco on the map, and of course led to GM and so on and so forth. As we are learning to invent these vehicles that are going faster and are able to have more meaningful speeds, beyond the slow speeds that we had been accustomed to, then people are starting to pay attention to the aerodynamics of the vehicle. Some of it was because of the functionality of the vehicle and its ability to go faster and be more fuel efficient. And some of it was because of the aesthetics of the vehicle. And along those lines, the 1934 Chrysler Airflow was a design that kind of embodied a lot of these aspects. It has both the functional efficiency and effectiveness, as well as it had the aesthetics. It's as you look at that vehicle, you see that it's absolutely a pleasing vehicle to the eye, so we are starting to design vehicles that are becoming a status symbol in the society in some ways, and so on and so forth. So we're advancing our way through of them. About the same era, Citroën introduces the first front-wheel drive car. So now we are moving sort of from, we are learning how to better propel our vehicles. Now, interestingly enough, as you may know, the front-wheel drive vehicles did not really catch on until the early 1980s, where Honda came up with, they perfected the McPherson strut type suspension that allowed for this large space on the front end that we could package the engine and also implement front drive. But nonetheless, Citroën was way ahead of their time, and it happens to be that this creation was the brainchild of André Gustave Citroën, the founder of that vehicle. Now we're kind of marching our way towards World War II, and we're getting just beyond the Great Depression that had gripped the world, and then we have the creation of the original VW Bug in 1938, and it was launched by none other than Hitler to a great kind of show and affair. And the story goes that Hitler and Ferdinand Porsche cooperated together to make VW Bug a reality. It was the vision of Hitler to have a vehicle that was simple and yet it could be mass produced and be effective in transporting people. And then Porsche came up with that design. So in a way, Porsche was the genius engineer behind it, and Hitler was the sly politician that made it one of the most popular cars around the world. And to this day, you can go anywhere and you can show someone a picture of this vehicle, and they would know what vehicle it is, which you cannot say that about a lot of vehicles. Now, this one being an exception. The same thing is true of Jeep, that if we show someone a picture of the vintage Jeeps, or even the new ones, it doesn't really matter, then more likely than not, one is going to be able to recognize it. And notice that this is now in 1940 and it's right at the start of the World War II. Willys Overland came up with this design, and it was really intended to be an off-roading buggy that could be used. And it just so happened that around the same time, the U.S. Army was in need of a troop transporter because they were getting into the World War II in a big way. So they had a bid out there for an effective vehicle that could be used on road and off road. You can say that Jeep was at the right place at the right time. And they managed to issue a contract for 16,000 of these vehicles, which even by today's standard is a pretty large order. But if we go back some 85 years ago, it's even a bigger order. So, but nonetheless, they issued an order for 16,000 of these vehicles at a price tag of about $738 or thereabouts. And of course, to this day, Jeep lives in infancy. And I never forget a conversation that I had at the time. This is in late 1980s, early 1990s, with one of Chrysler engineers. And this was the time that Chrysler had taken over Jeep and so on and so forth. And this engineer was saying, we're doing everything we can to kill Jeep. And yet you guys keep coming back and want to buy it. So we don't know what to do. But Jeep has been one of those amazing success stories in transportation. Again, it's one of those automobile creations that has existed forever. So we are learning to drive our vehicles faster. We're able to do things with them that we could not do before, and we have made them more aerodynamic. And then this is the first time that we start thinking about, well, how safe are our vehicles? Then we invent the first seat belts. Niles Boland had invented ejection seats for military aircraft, and later on he changed industries and started engineering seat belts at Volvo. The Volvo was the first company that put 3-point seat belts in their vehicles. And mind you that they were not the first seat belts. We had earlier version seat belts that were implemented in our vehicles, perhaps as many years as probably a decade before the date that I'm showing you here. But Boland came up with the first 3-point seat belts that similar to the ones that we have in our vehicles. And then again, as I said, now we are marching down through the history, and we're getting to an era that there is a lot of sort of social upheaval, frankly, with the Vietnam War and all the things that are going on. There is this revolution in the music industry, thanks to Beatles. And the Beatlemania is catching on around the world. And then there is this young, brash engineer that is working at Ford by the name of Lee Iacocca. And he dreams up a vehicle that would appeal to the younger audience. And this is the first vehicle of its kind that is built with a target audience in mind. And then he successfully shepherds this vehicle through production, and they show it in the 1964 World's Fair, and it was, bam, an instant success. Ford had a real difficult time keeping up with production of this vehicle. As a kid, I remember walking by a house that this car was parked in its driveway. And I remember just literally coming to stop on my tracks and being mesmerized by this vehicle. It was a silver colored Ford Mustang long nose and a long hood. And it was absolutely a beauty. I mean, you could just, standing still, you could just really feel this vehicle like accelerating and propelling forward, even when it was standing still. So it was absolutely amazing. And we started going in that direction. And then soon after, there was another brash consumer advocate by the name of Ralph Nader, that he published this book, Unsafe at Any Speed. And for the first time, he put the whole issue of safety and safety regulation in front of the transportation industry. And all of the safety regulations that we have in our vehicles today really start from his initiatives. Ralph Nader was active in this space for many, many years, and eventually rose to the prominent position of the governor of California. And he always had this polarizing effect in a way. Some people absolutely loved him and found him to be a consumer advocate that did work for the good of the society. And some people did not care for him because they consider him to be, a socialist or someone who was not really conservative enough, or whatever you want to call it. But anyhow, this promoted the passage of the National Traffic and Motor Vehicle Safety Act of 1966 that mandated seat belts in vehicles. That was promptly adopted by nearly all of the states. And then along the same lines, we invented in late 60s the airbags. And this was a GM creation, and it was implemented in Oldsmobile Tornado. And I got to tell you that the early day airbags had their detractors. In fact, there were people who would take delivery of the vehicle and would pull out or disable the seat belt by pulling out the fuse for that that was powering the seat belt. I mean the airbag. And then there are a lot of, as I said, the industry was not embracing this technology. They saw it as unnecessary, and they saw it as something that added cost, unnecessary cost to their vehicles. In fact, Lee Iacocca has written 2 books, and if you read his books, so the first one, he talks about how this, and again, this book is published in early 80s. He talks about how seatbelts are a good thing and airbags are absolutely a nuisance and another another good thing. And in fact, he calls them outright dangerous because he makes the point that, can you imagine having an explosive device less than a foot away from your face, and then having it discharge, and so on and so forth. And of course, we're all used to having this not only at our steering system, but also we have it around our vehicles. And as someone who has witnessed a lot of accidents post-crash and has analyzed the help of the curtain seat belts and so on and so forth, I mean, curtain airbags and so on and so forth that we have, I can tell you confidently that they are one of the essential safety devices that we have in our vehicles. So our thinking has evolved. So kind of, we made our vehicles go faster, we make them more aerodynamics, and we made them safer through different kind of things. And then in the early 70s, we're coming to realize that, hey, our vehicles are starting to polluting the air. And then we started thinking about it, and that led to the passage of the Clean Car Revolution and the Clean Air Act that was signed by Richard Nixon, the U.S. president at the time. And again, all of you in this room are young enough to remember, or too young to remember, the days where places like Los Angeles, the air was so extremely polluted that people were physically moving out of Los Angeles because there was just way too much air pollution in the city and that sort of thing. And because of that situation, California continues to be in the forefront of our vehicle technology. And now we're our vehicle technologies are advancing to the point where we find ourselves going to outer galaxies, and we're landing on the moon and having vehicles that would operate on spaces besides the Earth. And then we're moving on and finding ourselves for the second time in our transportation history with electric or hybrid vehicles. And again, as you saw earlier, the idea of electric vehicles and hybrid vehicles, neither one of them are new. It's just that in late 1990s, Toyota, through Prius, found a way of having hybrid vehicles that could have batteries that could last as long as the rest of the life cycle of the vehicle. And it has continued to be success to the point that a lot of our vehicles, today's vehicles, are operating within that space. And then now we're becoming more and more daring, and we find ourselves in a domain where we say that, hey, we can have these autonomous or automated driving vehicles. The first instance of that on any public roads happened in December of 2008, where to much fanfare, a robotic Prius delivered a pizza from downtown San Francisco to Treasure Island. Now, if you look at the sensory package that we have on top of this vehicle, and look at what some of you are working on, right, in terms of the auto drive or other vehicles, there is not really a whole lot of difference between them. So we have just all of this, and this initiative came as a result of a competition by DARPA, where it was part of Grand Challenge competition, initially off-roading and later on through city roads or simulated city roads. where a vehicle could go from point A to point B completely autonomously without any human interference. Once you started the vehicle, then it was all hands off, and this vehicle had to go through a certain amount of maneuvers and get to point B. The very early version of our autonomous vehicles through the DARPA Grand Challenge were in the deserts, in the California deserts, where pretty much there was a course set up that the vehicle traveled from point A to point B unassisted. And but today's standard, it was a relatively simple course. But nonetheless, for the time's technology, it was a pretty tall order. So, and that was the spark that has led to the autonomous vehicles that we either see or we talk about in today's transportation. It was one of truly great initiatives that has had a profound social impact, and then that sort of gave rise to other similarly great initiatives, and among those was the manufacturing and creation of Tesla, both as a company as well as its Model S, which was the early Tesla vehicles that truly disrupted the transportation industry. It was the first time that we allowed ourselves to get away from fossil fuels and dare to have a vehicle that purely ran on batteries. And that was quite a revolution. I know at the time that this vehicle was on the drawing board. There were a lot of naysayers, both about the ability of Tesla as a company to sustain itself and survive, as well as the electric vehicles being able to be accepted by the society and be driven for any meaningful purposes except for as a transportation curiosity or novelty. And a big part of it had to do with the fact that we have had a lack of infrastructure to support a lot of our electric vehicles, which incidentally, if I look at the past 13 years, since 2012, we've come a long ways in that regard. But I would submit to you that that's still a hindrance for many people to consider electric vehicles as their serious mode of transportation. There are a lot of families who have got two cars in a family, one for longer distance driving and the other one for local driving. The electric car being for the local driving and the other one being for long distance. Now, if I have an electric vehicle, then by its nature, let's just take Tesla, because everyone else sort of tried to emulate Tesla. I am entirely changing my philosophy of designing this electrical machine. All of a sudden, I am designing this machine that is less about the mechanical engineering and is a lot more about electrical and computer engineering or computer sciences. Effectively, the only mechanical things that we have are the wheels and some of the other components that we have in our vehicles, on our electric vehicles. The rest of them, more or less, are these electromechanical or purely electrical and software-based systems. Now, if I have that, then I have this really open domain for doing a lot of things with that vehicle. Most prominently, I can bring in a lot of sensing and a lot of intelligence into our vehicle to the point that we can elevate that vehicle to levels that were not possible with a purely mechanical machine. Some of you may be familiar with the levels of automation by Society of Automotive Engineers, and we have those levels go from 0 to 5. 0 is a vehicle that has no automation associated with it. Sort of, if I take a vehicle of 30 years ago, for instance, that would be level 0. I noticed that for the longest time, since the inception of vehicles till the turn of the 21st century, our vehicles were level 0. And then we started putting in driver assistance or ADAS systems into our vehicles, and that elevated the vehicles to level 1. That meant that the vehicle had some abilities to do some things for us, but nonetheless, I still has a person to drive it. And then if I move myself to a partially automated system, where many of our current vehicles are like that, then they are in that level 2 space. And then if I now move up higher and provide more autonomy in the vehicle, then I find myself to be level 3 and 4 and 5. And notice that some of the vehicles that we currently have are level 4 or level 3. And then I am estimating that a sizable number of the vehicles that we're going to have by 5 years from now, 2030, are going to be in that space of level 4. And then I am estimating that by 10 years later, hopefully in my lifetime, right, we're going to have vehicles in full autonomy and level 5. Now, some of you may be thinking that, well, wait a minute, we already have vehicles that are fully automated. In fact, if I were to listen to Tesla, Tesla says that the future of autonomy is already here. So why are you saying that, I've got to wait till 2040 to get to this fully autonomous or level 5 systems or level 5 vehicles? Well, my reason for that is because even though certainly one could envision the robo-taxis as a fully autonomous vehicles, which they are in many instances, they are not a widespread slice of the vehicles that we drive. And so to me, in order for us to have that full autonomy, then we have to have a meaningful portion of our vehicle production that is in that space. And we're not there yet. Certainly we have these sparks of autonomous vehicles. Some of you perhaps have seen these autonomous vehicles in places like San Francisco, Phoenix, Arizona, Las Vegas, and so on and so forth, where we have these robo-taxis that, are operated by Uber or other rideshare companies. And certainly, they are a great start. And ultimately, what we're trying to do is we're trying to push the vehicles to think like us, and we are finding to be extremely challenging. And the big reason is that our cognition is so highly developed through our evolution that we are able to do things that no machine is able to do yet, thank God. So there's still hope for us and there's still need for us. But nonetheless, if we were to have that autonomy, obviously, that would have a significant impact on the society, similar to the impact that the Model T had on the society. Imagine being able to drive from here to Blacksburg, Virginia, where I have to do right after the seminar, without having to be tied to my steering wheel and having to be present every second to pay attention to the roadway. Imagine being able to do that in the comfort of my own vehicle while I'm able to clean up my emails and do a few more things that are I've been leaving behind as a result of having a lot of fun with you guys. And then I am optimistic that we are going to do that because of the proliferation and normalization of the wide variety of sensors that we have in our vehicles. And it's just a matter of time that that is going to happen. And someone like me can drive from Columbus, Ohio to Blacksburg, Virginia with minimal attention to the vehicle, and the vehicle pretty much is able to deliver me door to door. Again, as I said, we are moving to make our machines think like us, act like us, but in my opinion, we still got a long, long, long ways to go. And one of the challenging aspects of reaching that point, in my opinion, is the lack of necessary infrastructure for making our vehicles aware of their environment. Now, you guys have got a great deal of research through NextCar and other initiatives that you have that is pushing us in that direction. And certainly, you know, that research is really significant in terms of the awareness of the vehicle within that space. Now, if I were to kind of step back a little bit and ask this somewhat philosophical question about this autonomy and autonomous vehicles, then I've often wondered, is the technology driving vehicle autonomy, or is it our desire to have autonomous vehicles that is driving the technology? And I must admit, depending on how I look at this, I am able to see it from both ends. So on one hand, I'm not able to have autonomous driving unless I have these advanced technologies. So one could, from that perspective, one could argue that, well, you know, autonomous driving is coming about because we are developing these, or we have these technologies. And on the other hand, I can make the argument that, well, you know, in the first place, we're developing those technologies because ultimately we like to have autonomous driving. So this whole issue of what is driving what becomes significant. And the main reason is because, you know, you know, are we putting the emphasis on technology development, or are we putting the emphasis on autonomous or machine development kind of thing? And then the other aspect is why is these autonomous vehicles important to us? And in my opinion, a critical aspect of it is safety. As you may or may not know, a large percentage of the accidents that we have stem from the fact that we have human errors and that sort of thing. And we can get our sensors and our vehicle autonomy to a level that it is able to be less prone to the accident than you know, than a human being. For instance, a lot of accidents happen because of drowsy drivers. With a autonomous vehicle, I don't have any of that, and certainly, so it kind of feeds into our notion of safety for our vehicles that has been developing since the inception of the vehicles, and then I believe that as we bring in more intelligence into our drivers, then it becomes more and more safe. So the technology is driving the electric vehicles. The electric vehicles are driving autonomous vehicles, and then we have this emphasis on automotive technology. That part of it is driven by safety. The other part of it is driven by climate change. And I think, irrespective of what stance you hold on climate change, it is undeniable that our environment is changing, and one can make the argument that a lot of what we do is because of that. So many years ago, back in 2012, I wrote this editorial about the future of automotive engineering technology, and I mentioned in that editorial that I am excited about our future vehicles because we are moving towards bringing many of the things that we have been working in our laboratories to practice and implementing them. And again, this is 13 years ago. And I can tell you safely, things that were on the drawing board and on the laboratory benches at the time are in practice today. And things that you guys are working on that are on your lab benches today, I promise you, in 5-10 years from now, are going to be in practice. So with that said, I would like to thank you for your attention, and I'll be happy to answer any questions you may have.
Thank you very kindly. We have time for questions. I'll start with a kind of a broad question, but you mentioned safety. Do you think that will be the driver for the adoption of automated driving vehicles more than convenience features? And I'm sort of making a distinction between safety perhaps coming in from a regulatory perspective or user convenience features, which is really more of a market acceptance kind of thing. What do you think?
Well, if I reflect back during the past 10 years, and in terms of our acceptance of autonomy and vehicle autonomy, I believe that it has been mostly driven by the convenience factor, and the safety has been a byproduct of it, as opposed to safety driving it. To give you an idea, I love the vehicle that I drive today, simply because in my short commute in the morning on a highway, I can engage my adaptive cruise control, and more or less I am driving somewhere in level 2, level 3, and I can enjoy my coffee and not have to be tightly to my steering wheel. So you see that is a convenience factor. When I drive that vehicle over long distances, it's a lot less fatiguing than, let's say, a vehicle that doesn't have that same level of automation in it. Now, that having been said, that vehicle also is safer, but and the safety is coming as a result of the byproduct. If I try to make a lane change maneuver and someone is in my blind spot, then it's going to beep at me, or if a car in front of me comes to stop, it's going to stop even without my interference, and so on and so forth. And so safety, I believe safety is the byproduct. It will continue to be the byproduct. And I think that ultimately our push towards autonomy is going to be because we like to have more creature comfort and more convenience factors in our vehicles.
I'm not arguing with you, but I'll bring up a point to just observe that some of the technological advances in our generation, they're obvious to the younger generation, but to us, we helped develop them. Anti-lock braking,
Yep.
electronic stability control. Those are things where the technology, you showed the 3-point seat belt and the airbags.
Right.
Those are all things that began as technology and became regulated into being part of every automobile.
Yes.
So maybe what you're suggesting is something similar will happen with automated driving features. As they keep improving, eventually they become safety features and could even be regulated.
Yes. Yes. I believe as they become more mainstream, then they will become accepted and the norm to the point that people would expect them to have them in their vehicles, and could dictate regulatory actions. Yes.
Please, Dennis. You know, I'm not completely sure that the microphone works, but maybe it works for the online people, so let's use it. Speak up.
I turned you on.
Oh, okay. Thank you. I have a question, or maybe just wanted to get your thoughts on really the social aspect of it, which is, I think it's not a far stretch if you look at the current automotive space that companies are really transitioning to a subscription-based model and a lot of services that are being delivered to customers. Is there, what are your thoughts on how this would really intersect with automation? I don't think it's a far stretch to think, as you can see with Tesla and the full self-driving package, that it's being sold as a subscription. How does that affect, the adoption of a lot of these technologies from an ownership perspective, how people are going to adopt these? Does that not hinder people's adoption of the technology because they don't want to, pay as you go kind of service to get a lot of these technologies? Just, of course it's an opinion, but I just want to get your thoughts on that perspective.
What a fantastic question, Dennis. And I got to tell you, I'm gonna have a short answer and a long answer for you. The short answer is that I believe it actually would accelerate the adoption and the integration of technology in our vehicles as we go to that subscription-based kind of model that you put it. And let me tell you why I see that. That means that there is more of a convenience for me than having to worry about the maintenance and the upkeep of my vehicle. Now, that, however, requires a change of paradigm in our consumers. That change of paradigm is not going to come today or 5 years from now, but I believe it will eventually come. I've had friends who they only lease vehicles and they say, I like to drive a new vehicle and not have to worry about any maintenance or anything else. And at the end of 3 years, I'll go and return the vehicle and get another one. Now, they're paying handsomely for it, but nonetheless, that's their paradigm. The other thing that happens is that it will really opens up the integration and recycling of a lot of technologies into our vehicles. I've got to tell you that some 40 years ago, when I was a graduate student like you guys, we had on Friday afternoons, we had these sessions that we would sit around, and as the young kind of professionals and engineers and students, we would discuss different things that could make this profound change in our in socially and technologically. And one day I said, what if we have a vehicle that we don't have to put any fuel in it? And everyone looked at me like I had 3 heads. And they said, what do you mean? I said, well, what if I have a vehicle that has a small nuclear power pack and that my vehicle comes with it? It lives through its life. And then after its X number of years through its life, I turn in my vehicle, the fuel cell, the nuclear fuel cell is recycled, rejuvenated, whatever you want to call it, and then installed into another vehicle, and we go from there. And I got to tell you, that's where I see us going. If I were to come back some 50, 100 years from now, then this whole notion of us putting this fossil fuel into our vehicles is kind of going to be completely foreign. And this whole notion that every 400 miles I've got to stop to either charge or put fuel in my vehicle is going to be entirely foreign. I buy my vehicle and I am going to drive it until it's time to turn it in and get a new one. But again, that's just things to keep in mind. I think we are going in a direction that is going to be vastly different. And by the way, these miniaturized fuel cells of nuclear persuasion are not far-fetched. I understand that they exist. It's just that outside the reach of the public.
Yes, Yuvraj.
So I have a question about like when we make projections such as we are going to get level 4 vehicles in 2030. Now, we have manufacturers like Tesla claiming that we have full self-driving, but now the problem is that I feel that there's a lot of subjectivity involved, because how do you define the ODD, right? The operational design domain could be like, I'm designing something that goes drifting on a S-curve, right? So now when we make these projections, what's your opinion on, should we have some sort of standardization on the way we define level 4 or level 5, or is it something that should be more like, okay, up to the manufacturer instead of the regulator?
Excellent question. I think it should not be up to the manufacturer or the regulator. I think it should be up to the some level consumers and some level researchers like us to perhaps make that determination. The manufacturers are in the business of having economic gain. They're in the business of selling vehicles. So if I am Tesla and if I'm able to hype the technological prowess of my vehicle, then dude, I can sell a lot of them. I can get a lot of people excited about it. Even though it may not be entirely founded and it may not be entirely on sound technical grounds. And then it is really up to us as scientists and researchers to kind of pull the veil back from that hype. And then I believe that getting regulators involved in this early in stage in technology development is going to hamper that technological development. I think we will do ourselves more harm than good. But there are certainly space for professional societies, Society of Automotive Engineers, or a similar kind of professional society that consists of all of us, right, to get involved and bring steer the technology and its acceptance and its promises in the right direction.
Thank you. Good question.
Mehdi,
More, Kadir.
So you have been giving the whole background, how the technology evolved, right? I may have missed, but connectivity, connected environment, how it will impact the vehicles, and then we are hearing the buzzword of software-defined vehicles.
Yep.
How do you see those factors impacting the evolution of automotive systems?
I think that our automation and automated vehicles will not happen until we have both of those. I believe that ultimately that is currently the Achilles heel of our autonomous driving. I can take an electric vehicle or automated vehicle from many manufacturers and put it in a controlled course test track, something of the nature of the kind that we have at TRC or we have at M-City or we have at Carnegie Mellon and so on and so forth. And that vehicle is going to be able to maneuver and operate successfully. And it's ultimately the connection to the infrastructure within the naturalistic driving that is going to define the success of autonomous driving or level 4 or level 5 driving. And that's why on my chart, I was putting them some 5 to 15 years away from now, because I believe that it will take that much time for us to develop that infrastructure within our cities and within the naturalistic driving that is required. And then we have already opened the Pandora's box to software-defined vehicles. And more or less, we are moving in that direction. And if I believe everything that I hear about AI and its ability to generate software codes, then I would submit to you that the proliferation of AI is going to further accelerate that software development that is going to be needed for SDVs, software-defined vehicles, and so on and so forth. So I think we are fast approaching that direction, and we are in fact accelerating, and we are gaining momentum in that direction. And that is going to be what is required for us if we're going to get to level 4 or thereabouts in 5 years. That is ultimately what's going to be required for us to have. Great question.
Last question. I'm sorry? Online questions, please, online people, speak up.
Oh,
It's a message. Let me, in the chat.
it said on the MAE website, they had said that the seminar starts at 4 o'clock.
I'm sorry, I am missing it. Where do you see it? Oh, well, that's someone, the MAE website obviously was mistaken. What can I say? I am sorry about that, but this seminar was at 3 p.m. So Antonio is asking a question: would that technology make cars too expensive for most users? That's a good question. I would say, if you want to take it.
I think that if again, history has been any indication, I would argue, Antonio, that it's actually going to be the opposite. That the more we proliferate within these technologies, that the more reachable, economically reachable, our vehicles are going to become. To give you an example, some of you may remember that the early Teslas, the Model S, was north of $100,000, right? And just recently, Tesla announced vehicles that are in the range of about $30,000. So it just goes to show that the economies of scale are getting a hold of the whole technology. I recently traveled to China, and I can tell you there that more or less there aren't really, at least in Shanghai that I visited, there were not really a substantial, and there wasn't a whole lot of appetite for gas-powered vehicles, and everyone was buying electric vehicles, simply because if you bought a gas-powered vehicle, you had to pay 100,000 yuan to get a tag, a license plate for your vehicle. In contrast, your electric vehicle license plate was free, right? And they had plenty, of of different types of electric vehicles. Like I was astounded how many different types of electric vehicles they had, and how accessible they were in terms of their economy and their price range. So I think we're going in the direction of making all of this more accessible to our audience, to our consumers.
My experience is when I have to renew the EV registration, I have to pay more than the gasoline vehicle.
In the U.S.
In US,
In the
yes,
US.
yes, yeah.
Yeah. Because you're not paying the road tax at the gas pump, right? So
Well-
in the US, it's a completely different picture. But in China, it's absolutely true. If you want to drive a vehicle in Shanghai or Beijing, it better be electric. Yeah.
All I can say is that I've come to realize that our social priorities are different, at least at the moment. And I'm going to stop right there.
So let's warmly thank Professor Ahmadian for his seminar.
Thank you.
My apologies to those who showed up at 4:00 thinking that the seminar started at 4. I'm not sure how that happened, but I'm sorry. But on the other hand, between the online and the in-person attendance, we had a good audience. So thanks
Thank you
again
so
for a
much.
great seminar, Mehdi.
Thank you.
Thank
Thanks for
you.
hosting me.